Hi, Kansasfest. I'm Eric Rangell from Pennsylvania, and I've been using an Apple since 1983 when my brother got an Apple IIe. So I remember playing Apple Presents Apple in the computer store. So these graphics around me are from a class that I took in Brooklyn College for when I was about 15 years old on low-res graphics, mostly. Okay, so today I'm going to talk to you about Ted Nelson. Okay, we're going to go on a hyper adventure and reverse engineer Ted Nelson. So who is Ted Nelson? I didn't know him until I found out about the project to archive his junk mail on the Internet Archive, and these are some pictures of what's in his junk mail. But from that, I found out about his research in hypertext, and I really dug into it. So, looking at these pictures, you can see that he collected a lot of ads and information from reader service cards from magazines. And now that it's on the Internet Archive, there's some fascinating things here. Like, look at that Heathkit ad, and in the middle, women entering data into a PDP-4 computer, and the PDP-7 on the right. And he was also very much into Apple products. On the lower left, it says there was an 11-foot high model of the Apple Macintosh when it was first introduced. So we'll find out more as we go. So his main accomplishments are: he is the inventor of the back button. Thank you, Ted. He insisted that there be a way for users to keep a stack of all the links that they visited and be able to navigate backwards. And some of his other accomplishments are here. He claims to have invented the first rock musical in 1957, and he has a YouTube channel where you could explore a lot about his work. So he coined the term hypertext in 1962, and it stuck to anything that we can link to from a text document. And he wrote a book in the 1970s called Computer Lib, and that's actually what Steve Wozniak says encouraged him to develop the Apple I computer. So that's very significant to our community. The word processor that he worked on at Brown University was used by NASA to document the Apollo missions. And he has worked over the years to build prototypes of hypertext systems with visible connections to their sources. And I'll show you some demos of that. And he also has a paper about a multi-dimensional database that can extend spreadsheets and databases, and it's like a unifying vision. Even code can be put in there. Okay, so what attracted me to Ted Nelson? His life story is very human. I could relate to it. He spent a lot of time with his grandparents, and he became interested in computers in his college years. So he was in college in the late 1950s, and I was in college in the late 1980s. So I see a parallel there, but he made mistakes in his early career in business. I could relate to that. And he had love, loss, dreams, and failure. Hey, he's human. So Ted had a few successes that he's very proud of. And that's a good message, that even that our work has meaning personally, that even if we don't build something great that changes the way people use computers, that's good enough for us. Now, his ideas have not taken hold in the mainstream yet, but it's a paradigm shift, and it takes time. And the first people to change a paradigm aren't usually the ones who get recognized and successful. So he's leaving us a legacy, a lot of writing. I have several of his books. I'll show you some prototypes, and you could explore his junk mail archive, which is just fascinating. Okay, so I wanted to reverse engineer Ted Nelson. And I really wanted to understand one of his programs for the Apple II. So there's a lot out there if you want to learn more about him. He has a whole series of YouTube videos. He has an autobiography that you could order and read. This document about where his hypertext ideas came from, he summarizes his career and all his ideas and his meaning behind them. And his junk mail is on the archive. Jason Scott and Kay Savitz collected it and scanned it. They fully had it funded by donations, so that's an amazing project that completed. And there was an attempt in the 2000s to collect all this documentation about his early projects, where he worked at Swarthmore College and developed his Xanadu prototypes. Xanadu is the name of his main system that he envisioned. So I just want to play something from his junk mail from 1966.
The conference of which this discussion is a part is directed toward innovation in the means of education. A half day is devoted to clinics for solving some 26 identified problems which managers face in effecting educational change.
So now we know there were only 26 problems with corporate training in 1966. But it's great that we have that on the archive, and anybody who's researching can find it. Okay, so this is the Sunless Sea website, which is on the Wayback Machine. So what does this have to do with the Apple II? Well, Ted designed a word processing system in 1972. Now, does anybody remember word processors from 1972? No, they weren't around. They didn't exist yet. He worked on a system he liked to call JOT, Juggler of Text, and it was originally designed for a tape and a teletype. And he came up with a way of storing characters in memory and on tape so that you just keep appending characters to spans of text. You keep adding to it, and you have all the versions of the document available. They could all be reconstructed from pointers. So in 1982, he ported that system to the Apple II. They tried AppleSoft Basic, but they found it had too many bugs. And then in 1986, it was rebuilt in Forth by Steve Whittam, and it has been archived by Jason Scott. So this is your user manual for the JOT system back in 1982. So back then, it was a 13-sector disk. So if you have a 16-sector disk drive, you needed to load the basics disk. Does that bring back memories, anybody? Okay, so I'm going to demonstrate JOT now. And that disk label is from the image of the software that's archived on the Internet Archive. So just so you know, all materials and links from these presentations are available on my GitHub. And I have a YouTube video that goes into much more technical detail about this presentation. I'm going to give you more of a high-level overview. Okay, I'm going to run this in Micromate, which is an amazing Apple emulator from the gals in Australia, Melody and April. And I have JOT version 0.53, and let's boot it up. Okay, it's loading. Okay, remember that sound. We're going to talk about it later. So here it is displaying Ted's essay. He wrote this as a demo, and he has to invent his own systems. I feel the same way. Okay, so what it's showing you is a system developed for writers, and he came up with his own keyboard language. So like the space bar advances one word at a time, and you can insert words in between words. Okay, and then when you press return, you hear beeps. So that is 2 beeps. Now the space bar advances by 1 sentence at a time. So this is his idea of modes. So it found the question mark, and it considers that a sentence as well. When you press return, Okay, it went back to 1. That's actually a bug. It should go to 3. So you press return again. Now you hear 3 beeps. Now the space bar advances a paragraph at a time. So now it's going to scroll down to the next paragraph, and it reads data from the disk as it needs it. So there was just a little pause there while it read more data from the disk. So he's actually storing the data in a structure he calls the Model T enfilade. It's his own data design where it keeps appending and it keeps updating pointers. So let me go back to word mode. 1 beep. Okay, so now the arrow keys are 1 level above the space bar. So space bar advances a word at a time. The right arrow will go to the next sentence. So I found a period there. So it's always 1 level up. So now the left arrow will go back to the previous sentence. And you notice that the cursor is wide. It's like filling in the gaps, like 2 spaces after a sentence. Now, what is really cool is his way of rearranging text. So if I type the slash key, it is going to delete the next sentence. Okay, so, or the next word. It depends on what mode you're in. So it's the same level as the space bar. So if I hit, go to sentence mode and hit slash, okay, I just deleted a sentence. And now what I could do is go to the right. I could press space bar to go forward 1 sentence and then type an @ sign, and it will paste that sentence that I just deleted right at that point. So he was designing from the perspective of a writer what a writer would need to do, like moving around sentences and moving around paragraphs. So that is the way he approached software design. So now I'm going to exit. Control E is a save and exit. And I'm going to show you how I reverse engineered this system. So this is Forth, and Forth is a threaded interpretive language. All that means is it's a bunch of words which could be considered like objects which talk to each other, and they're all threaded, so they depend on each other. So I decided I want to learn how this system is constructed, so I'm going to go to the monitor. Okay, and now I wrote some assembly code, which I'm going to paste into Micromate. Now, I got to thank Melody for getting this done. Paste speed, you could paste data in, and I'm going to warp during paste, so it'll be at full speed mode. And I'm going to copy and paste this assembly code in. So Command A, Command C, and Control-Shift-V will paste. So now I'm coding. Cucumber, can you code this fast? You probably can. Okay. So I had to patch some bytes. I had to write some code to print out words. So yeah, Forth is a dictionary of words, and they're all related to each other. Some of them are machine code. So the lowest level are machine code, and then it's built up from there. Words that call those words, and words that call the words that call those words. So it's almost done. Okay, it is now. And now if I type 8700G, I pause it, you're looking at the source code for JOT. So up here at 8118, this is the definition of JOT. JOT rescue $0 text safe exclamation mark. Text safe is a variable. 0 puts a 0 on the stack, and exclamation mark is a poke. So this is the address of a variable. You're poking a 0 in that variable. But then it looks like a high-level language. You're emptying buffers. You're loading text. You're going to the top. Cacophony. What do you think that is? Remember that noise that it made at the beginning? Well, that's what I wanted to reverse engineer. How does it make all those sounds? So if anybody wants to look through this source code, it's on my GitHub, and I do have an annotated version of it here. So I just put some comments on it, just broke it out to make it a little easier to read. So it's possible to go through all this and understand how the system is built. It will take time. It's not an easy thing to read. Okay, but what I'm going to do is swap disks. Okay, this is a Protos version of Forth called Mad Apple Forth. I don't know where it came from. I downloaded it at some point. If anybody has history on it, let me know. But here are the words that it comes with. So I added some object-oriented machine language programming words so I could create objects, and it uses assembler as a vocabulary that it builds on. And I also added some things like to execute a text file containing definitions of words, to type a text file, and things like save quote allow you to save the whole system image into an executable file. So then the next time you run Forth, all the programming that you did is loaded back in. Okay, so now it's reading in some words that define communication with a mockingbird. Now notice how modular you can build your system. So if I only want this thing to play Frere Jacques, the only notes I need are the notes in the song. So like I could define C, D, E, G3, G2, and just what I need. Now I'm defining a word called RU, which plays C, D, E, C. And if I type RU, okay, if I type brother, morning, and ding dong. So like if I want to say ding dong ding, ding dong ding, I put two ding dongs. So if I want to play the song, I define it this way. I have a loop. So a do loop in Forth, you're putting two numbers on the stack, and it's going from the 0 to the 2, non-inclusive. So it'll be a 0 and a 1, and it'll repeat RU twice. So now I can play Frere Jacques. Okay, and what's great is the immediacy of the programming. Like, if you were just typing this interactively, you could run it right away. And that is the tight loop that we had in early Apple programming. Okay, Forth is actually used to control radio telescopes. So it's a fascinating language. Okay, so now what we're going to do is port the sounds from Jot into Mad Apple Forth. So let's reboot this disk. Okay, so now I want to write some code in Mad Apple Forth that will reconstruct the sound routines in Jot. So at the lowest level, there is a machine language sweep function. And it turns out you have to pass in 4 parameters, and one of them is the address of the speaker, the -16336 or C030, and it has self-modifying code that will poke it in one of these 4 places where I put the FF, EE, BB, and AA. So I'm just going to type in this code. I'm just going to copy it and paste it in. So I'm going into hex mode, so it uses hexadecimal characters, and paste. So it's defining the object now. Okay. Now it's in memory, and if I type words, I now have a sweep function. So let's test it out. Okay, so here's a test. Okay, before I test it, I need to change a setting here for input. I want not to warp during paste because I want to use the Apple 1 megahertz speaker. So now let's try that again. Okay, that was fun. So you could see how you poke different values and you get different sounds. Okay, so now I'm just going to paste a few other things so you can see how I rebuilt the code. So there's a click and a glick object. Okay, so we're defining a... And then, so I just defined click and glick, and to test them, I'm using loops to hear how they sound. Okay, so like the first one was click, the second one was glick. Then there's an oscillator that's defined, So I'm going to define it. There are two oscillators, and I'm going to test each one. Okay, so you hear different tone qualities. Now we're going to define a clack and a cluck. Okay, so those are noises that he uses. And now we're going to define the main sound routine, and it's a case statement. So let me just set it up and then you'll see what it does. Okay, so the way it works is you put in the number of a sound. So if you type 0 sound, you get a beep. If you type 1 sound, you get a click. 2 sound, a different click. 3 sound, a sweep. 4 sound, another sweep. Okay, so in his cacophony routine, he plays a whole bunch of sounds at once, one after another. So here I'm setting a variable called muffler to say play sounds up to number 8. Okay, so there are 2 extra sounds that you didn't hear in that intro that it plays. So for the intro sound, it's actually setting muffler to 6 and then playing that. So this is the intro sound. So we've successfully ported the sound that Jot uses to Mad Apple 4th. And in certain modes, he only uses 3 sounds. So you could test that as well. Yeah, you only heard 3 sounds there. Okay, and now just another little test here. Good. So now that you have these sound routines, you could do your own things with them like this. Or, okay, so now that you've done some coding, you can save this whole system yourself as a new file and use it whenever you want it. Now, Ted's main interest was showing visible connections to sources on web pages. So what he wanted was to take a document and have a bridge showing a link to the other document. So he wants to be able to click here and see the comments of Charles Kinboat, and they are here in this document. So we can do this in JavaScript these days and have it draw these bridges between documents using this demo. These are called Ted Nelson documents because they give you visible connections, but they're not structured fully as Ted envisioned. He has grander ideas for navigating through these connections, but this gives us something to start with. So imagine surfing the web and being able to take a phrase and find a whole commentary about it like that. It's pretty cool. This is an Apple IIgs running HyperStudio, which is a precursor to HyperCard for the Macintosh. It is one of the first hypertext programs available, the innovation of Roger Wagner Publishing. So I created a sample demo stack using HyperStudio to illustrate how it works. So basically, you can add links onto any photo. So you could have invisible links. So like this parrot, when you click it.
Hi, I'm Ted Nelson, here to tell you about a document system I've been working on a long time.
So one unique thing about HyperStudio is it included a microphone, and you could record your voice in 8-bit audio. I put an Easter egg on the red spot of Jupiter, and what I'm going to demonstrate is Douglas Engelbart's chord keyboard. So he had in his mother of all demos from 1968, this was at SRI in California, he was demonstrating all kinds of groupware technologies, and he invented the mouse, but he also had on his left hand a chord keyboard that looked like this. So I designed my own system where I can enter hex numbers like that. So 41 is the hex code for A. So I'm doing these bits like my ring finger is doing that 100, and the thumb is the strobe. So if I want to do a B, it's 42, a C is 43. So you could learn to type in hex this way. The next demo I want to show you is HyperCard for the Mac. Okay, so here's an example of a Seinfeld stack that was created back in the 1990s. An unabridged guide to nothing, and you have hyperlinks for advancing. That's Kramer's voice, so there was voice recording. And then you had text boxes, you had pictures. So you were able to browse through these, and then there's another, find out about the actors, and and mix it in with audio. And then you have index pages, so it was a way of browsing in a nonlinear manner. On this computer, you're seeing a prototype of Ted's vision of a 3D document system with visible connections. So it's using OpenGL, so like when I right-click the mouse and move, you're moving in a 3D manner. And then what you can do is zoom with the arrow keys and go behind. So like these are documents that are related to these documents, and they are really a flight of documents, and you could see there are bridges between each document wherever the connections are defined. And then as you're reading, you can navigate left and right to the connections. So I just went left. Now I'm going to go to the right and read this document, and I can move up in this document and left and up. So as I move through the document, you are seeing different documents being brought in. They're flying in from the background and to the front. So this is called Xanadu Space. Now it has a system behind it called Zigzag, and his theory is that by organizing data in different dimensions, you can have much more powerful system functionality. This is an exhibit that I will be presenting at VCF East in Wall, New Jersey in October. It is powered by Hyperduino by Roger Wagner. So what Hyperduino is, it's an Arduino that hooks on the back of an exhibit, and you can have these touch pins so that if somebody comes up and touches something, it'll play a sound from an MP3 file.
Ted Nelson is a visionary who imagined the ideas of hypertext
and LEDs light up.
In the 1960s, and they were much grander than what we currently have now on the World Wide Web.
So I hope you've enjoyed this presentation. This is the GitHub site, Rangell/KFest2020. It has all the links for you to explore further, as well as the disk images, the fourth code, the mini assembler code that I demonstrated, and the presentations. Enjoy. Feel free to contact me if you have any further questions or interest in researching Ted Nelson.